Okay, today's bell work is just a refresher of last time's lesson on our 30, 60, 90s. So remember, and our 45, 45s. So if we go and put in our ratios, this is going to be x, 2x, x square root 3. Over here, 45, 45, x, x times square root of 2. All right, so I'm just going to put the answers in here really fast, and then we'll go from there. So this first one actually doesn't look like a 30, 60, 90. I know it's not because 4 and 7 are not half each other. So this would be one where it's like, ooh, if it's not a special pattern, how am I going to find that missing side? Oh, Pythagorean theorem. Every time you see a right triangle, guys, think Pythagorean theorem, special patterns, and then we've got our sine, cosine, and tangent that we're going to learn today. Those always run through my head. Every time I see a right triangle, I think Pythagorean theorem. Is it a special pattern, or can I use a trig function, sine, cosine, and tangent? So this Pythagorean theorem, so we'll go ahead and solve that. So it turns out that x, so I'm going to do 7 squared minus 4 squared, and then the square root of that. So square root of 33. Over here, this one is a special pattern. I can see that it's a right isosceles, so that makes that a 45, 45. So this is 8 root 2. Over here, I can also see that it's a right isosceles, so this is 8. So we're going to divide by the square root of 2. So this is going to be 4 root 2 and 4 root 2. Down here, on this one, 30, 60, 90, I want to get to the shortest side first, so I'm going to divide by the square root of 3. So this is going to be 4 root 3. And then I'm going to multiply that by 2 or double it to get the hypotenuse. And then here I know my hypotenuse, so my short side is going to be 6, and then this other side is going to be 6 root 3. And another 30, 60, 90, it looks like the one that we just had on number 4, except it's oriented different. So I'm going to divide by the square root of 3 to get to the short side. So that's going to be 4 root 3, and then our hypotenuse is going to be 8 root 3. Okay, 45, 45, I know the hypotenuse is 20, so I'm going to divide by the square root of 2 to get to a leg, so that's going to be 10 root 2. I know the legs, so 4 square root of 2, I'm going to multiply by square root of 2 to get to the hypotenuse, so that's going to be 8. And then here's a 30, 60, 90, and so I'm going to divide by the square root of 3 to get to the short side, and then I'm going to multiply that by 2 to get to the hypotenuse. Find the diagonal of a square whose perimeter is 40, so here's our square. If the perimeter is 40, that means all the sides are 10. So that means this is now a 45, 45. So x is our hypotenuse, so that means x is 10 root 2. And then the equilateral triangle, whose sides are 10. So if my equilateral triangle, my sides are 10, when I drop that altitude in, this is 10, this is 5. This is my 60-degree angle, this is my 30-degree angle. So the missing height of the equilateral triangle would be 5 root 3. You would multiply that by square root of 3. All right, there's the bell work. All right, so we're going to be doing our trig ratios today. So the word trigonometry comes from 2 Greek terms, trigon meaning triangle and metron meaning measure. So notice that the vertices on our triangle are capital letters and the sides opposite them are lowercase letters. And typically we want the right angle to be a letter C. So opposite, so they come in pairs here, guys. So capital A is opposite lowercase a. Capital A is for the angle, lowercase a is for the side. Capital B, angle, lowercase letter B, side. And then capital C, angle, lowercase letter C for the side. That's the hypotenuse. All right, so really quickly, we'll just go ahead and put in, it says put in the label the missing angles or sides. So capital M, capital I, capital T. This is lowercase y, capital X, and capital Z. Those are kind of hard to tell the difference between. Down below, This is lowercase r, this is capital F, and this is side h, so lowercase h. And then the last one, we've got angle D, so across from it would be lowercase d, side j, across from that would be angle j, side e, across from that would be angle e, capital letters. Okay, when we're working with right triangles, we need to know what acute angle we're standing at. So we need to label that either with a capital letter, or sometimes we reference it with a Greek letter. So this letter right here is called theta. So I could say that I'm at angle A or angle theta. And when I'm standing at that location, I like to think of it as the triangle kind of makes a field, or, you know, a yard, whatever, and this is the fence. The yellow is the fence. And if you're standing right here in the corner, right here in this corner, you could touch both sides of the fence. So the one that's across from the 90 will always be called the hypotenuse. And then the other side that you're touching is going to be called the adjacent side. It's next to you. You're touching it. You're right next to that side. So that's why it's called adjacent. And then the other last side, you would have to walk across the field, or whatever you want to call it, to get to the opposite side. That's why we call it opposite. So it's important to know those labels for the sides of your right triangle. That's how we're going to define our ratios with the sine, cosine, and tangent. Now, if you draw this same triangle, so I'll come over here and make a quick sketch. But this time I move my theta down here to the bottom right. Well, hypotenuse, that's across from the right angle, always stays hypotenuse. So that one doesn't change. But now the adjacent side changes, because this one is right next to me. Adjacent is here, and then walking across the triangle would put me to the opposite side. So it matters where the angle is, and it matters how you label it. So adjacent and opposite side tend to switch places depending upon what angle you're at. Hypotenuse is always in the same spot. Hypotenuse is always across from the right angle. But adjacent and opposite can switch places. Okay, really quickly, I'll just put in with a capital H for hypotenuse, O for opposite, and A for adjacent, just so we can quickly look at these. You could turn this off and try to answer them yourself and then check it if you wanted. Okay, there we go. So like I said, you could do that by yourself and then come back and check it. Okay, so there's three main trig functions that we are going to be working with. The sine, which is defined as the ratio of the opposite leg over the hypotenuse. The cosine, which is defined as the adjacent leg over the hypotenuse. And the tangent, which is defined as the opposite leg over the adjacent leg. So it matters what part of the triangle you're talking about. So remember, when you set up a triangle, you always have to have a trig name. So what I mean by trig name is in this spot right here, you're going to be writing sine, cosine, or tangent. And then you have to have something that represents the angle. So you could say theta. We could have, oh, let's make that not a color. We could use theta to represent the angle. So I could say theta, sine theta. I could use a capital letter, cosine B. I could actually even put a value. I could say 72 degrees. Something in that spot has to represent the angle. And then over here on the ratio side, so the last part of your setup over here, you're going to have two ratios, whatever the length is. Now, sometimes you can leave the ratios as a fraction. So you could leave it like 4/5. Or, right here, sometimes you could just express that as a decimal. We could say it's 0.8, like that. So it just kind of depends on what you're after. You can leave it as the fraction, or you could change it to its decimal value. But every time you use a trig ratio, you need to follow that setup. You need to have a trig name, something to represent the angle by, and then equal to whichever two sides match your trig name. So this SohCahToa is the acronym that a lot of people use to help them remember how it works. So S stands for sine, O stands for opposite, H stands for hypotenuse. And then in the Ka, the C stands for cosine, A for adjacent, and H for hypotenuse. And then the TOA, the T stands for tangent, O stands for opposite, and A stands for adjacent. So that kind of helps you memorize those three, SohCahToa, SohCahToa. There's lots of other acronyms you could use to help you remember. But whatever you choose, make sure you just get the right ratio with the right trig name. Okay, so over here it says find each trig ratio. So notice I'll use blue to match our angle. So over here, sine A is angle A, that's in blue. So if I come over here, if I'm standing at angle A right now, this now becomes the opposite side, and this becomes the hypotenuse. So if I'm looking for sine, it's opposite over hypotenuse, so that would be A over C. Cosine of A, and then this piece right here would be adjacent. So cosine of A would be the adjacent side. So cosine is, remember, adjacent over hypotenuse. So adjacent would be the letter B, and the hypotenuse is C. And then the tangent of A would be the opposite over the adjacent side. So opposite side in our picture is letter A, and the adjacent side is letter B. So that would be the setup. You don't have to write the words adjacent over hypotenuse, opposite over adjacent. I just started writing that so you could see the ratio definitions. Okay, now we're going to switch letters, and we're going to come here to side B, or angle B. So when I do that, this now becomes the adjacent side. This becomes the opposite side, and of course the hypotenuse stays the same. So sine B, remember, is opposite over hypotenuse. So that's going to be letter B, lowercase b over C. And then cosine B, I won't write these ones out since I wrote them on the letter A. Cosine B is adjacent over hypotenuse, so that's going to be A over C. And tangent of B is going to be opposite over adjacent, so that's going to be B over A. So there's our ratios. We just got to make sure we get the right legs, the right ratios with the right trig name. Okay, so this one says express each trig ratio as a fraction and a decimal. So if you're standing at A and you're going to find sine A, that's opposite over hypotenuse. So the opposite side would be 12. The hypotenuse would be 13. Now, as a decimal, typically, if you can, 12 divided by 13, we usually write those decimals to 4 decimal places. So I'm going to say this is about 0.9231 as a decimal. So sometimes your ratio can be written as the fraction or the decimal. Okay, cosine A. So cosine A is 5 over 13. It's the adjacent side over the hypotenuse. So same thing as a decimal. 5 divided by 13 is about 0.3846. Okay, and then tangent A is opposite over adjacent. So opposite side is 12 and adjacent side is 5. So 12 divided by 5 is 2.4. So we don't need to, that one is exact, so 2.4. Okay, if I'm going to do sine B now, so now I'm at B. So when I'm at B, this is now my adjacent side, this is now my opposite side, and this is now my hypotenuse. So if I'm going to do sine of B, it's going to be 5 over 13, which we've already figured out that as a decimal is 0.3846. Okay, cosine of B is going to be 12 over 13. which we already figured is 0.9231. And tangent B is going to be opposite 5 over adjacent 12, and we don't know what that one is, so 5 divided by 12 is about 0.4167. Okay, so we can do ratios as fractions or as the decimal value. Okay, on this one, we just got to be careful here. Make sure you get to the right angle. We want sine A. So sine, if I'm at A, opposite would be 20 over hypotenuse, which would be 29. If you can reduce that fraction, go ahead and do it. 20 divided by 29, I think, is reduced. Okay, cosine of B. I'm standing at B, so now it's 20 over 29 again. And then tangent of B is opposite over adjacent. So there's our ratio. Okay, this one says find the trig ratios given that sine B equals 4/5 and angle C is a right angle. Okay, so let's go ahead and draw a right triangle. Let's put our right angle in, so we know that's going to be C, because that's where the right angle is. Now, A or B is up to you. I think I'll put A down here just so it kind of looks to scale, and B is right here. So remember, in words, sine B, this is the opposite side over the hypotenuse. So if I'm standing at, oh, let's see, I think I'll do it, maybe I should have done it the other way, sine B. Yeah, I think I'll switch those so that my shorter side, nope, I think I'll leave it, sorry. I keep changing my mind here. Okay, we'll just leave it. It doesn't matter if it's to scale or not. We'll get the numbers right. Okay, so opposite is 4, and hypotenuse is 5. So you need to have this other side here. So some of you may recognize this already as a Pythagorean triple and know that it's 3. Some of you may not. So if you don't, remember, if you see a right triangle, first thing that comes into your head maybe is Pythagorean theorem. So I would say x squared plus 4 squared equals 5 squared. And then I would solve that for x. So 5 squared minus 4 squared. So x is the square root of 9, which turns out to be 3. So that's how we would get 3 if we didn't recognize that as a 3, 4, 5. Okay, so now we're going to do sine of A. So sine of A is opposite over hypotenuse, so that's 3/5. And once again, you could also write that as a decimal. So 3 divided by 5 is 0.6. Cosine of B is adjacent over hypotenuse, so 3/5, which is also as a decimal, 0.60. And tangent of A is opposite over adjacent, and as a decimal, that's 0.75. So you could have it written as a fraction or a decimal, either one. Okay, find the trig ratios given that cosine A is 3/7 and C is our right triangle. Okay, so let's just go ahead and draw that. So here's C, and then cosine is adjacent, and this is hypotenuse. So let's put A right here, and I'll put B right here. So 3, 7. So this one is not a Pythagorean triple, so I'm going to have to do the Pythagorean theorem to find that missing side. X squared plus 3 squared equals 7 squared. So x squared equals 7 squared minus 3 squared. So x is going to be the square root of 40, and that's going to turn out to be 2 square root of 10. So this side right here is 2 square root of 10. Okay, so sine A is opposite, so 2 square root of 10 over 7. So we could leave it like that. We can have the radical in the numerator, which is a good answer. You could figure out what the decimal value is if you wanted. So if you do that, it's 2 square root of 10 over 7. So that's about 0.9035. Okay. Cosine of b, so cosine of b is 2 square root of 10 over 7. And that's about the same. So are you guys kind of noticing, we've had a couple of these now, that sine A is equal to cosine of B, that those always turn out to be the same thing. The sine of A is always the cosine, and the cosine of B always turn out to be the same. And then tangent of B is opposite over adjacent. Now, you can't leave a square root in the bottom, so you need to rationalize that. So if I rationalize that, I get 3 square root of 10 over 20. And if I wanted to figure out what that was as a decimal, that would be about 0.4743. So this is your exact answer. And this one over here is a rounded answer. It's a rounded decimal value. Sometimes those decimals turn out to be exact, but if you've got a radical and you change it to a decimal, it's going to be a rounded number. Okay, so this says use your calculator, find each value. So what it wants you to do is find the ratio of the trig. So remember, our trig function always has a trig name, followed by an angle, and then it equals the ratio of the sides, right? So when you type in your calculator sine 72, it gives you a decimal. So make sure you're in degree mode. So this is sine of 72 degrees. And it gives me 0.951. We'll go with 11. Okay, this number right here is your ratio of your sides. That's that decimal we were getting every time. That's our ratio of our sides. When you hit the sine button, it gives you your ratio of your sides. Okay, so tangent of 48. So let's hit tangent of 48. And it gives me the number 1.1106. So once again, that's the ratio of the two sides. So that's going to be 1.1106 about. And then the last one, when we do cosine of 12, that turns out to be about, I should be putting squigglies on these, 0.9781. So let's make those squigglies. It wasn't exact. So remember, that's your ratio of your sides. So cosine of 12 is 0.9781. That's the ratio of the two sides. If I knew what the lengths were, they would just always divide down. At 12 degrees, they always divide down to about 0.9781. Okay, now down below, notice what they give us down below. So down below it says find the measure. So right here, this is the ratio of the sides. This is given. But we're trying to find the angle. So to do that, we're going to do the inverse button on our calculator. So on your calculator, you have a button that says sine like this, and then right above it, you might see something like this. Okay? This right here, when I push this button, it gives me the ratio of the sides. When I push this button, that's the inverse button, it gives me the angle measure. So in your calculator, what you're going to do on this is you're going to say, okay, I'm going to hit the inverse sine button, and then I'm going to type the decimal in. Remember, when we're working with inverses, the input and the output switch places. So that's kind of what's happening here. We're kind of switching places with our input and our output. So 0.7261, and that's going to equal B. So that's going to tell me what angle B is. So I'm going to go inverse sine of 0.7261. And so angle B is about 46.5 degrees. Okay, so let's do number 5. So number 5 is the cosine of A equals 0.4801. So remember, this is the ratio of the sides. So I'm looking for the angle. So I'm going to use the inverse button. Anytime I want the angle, I'm doing the inverse button. So I'm going to do inverse cosine of 0.4801. And that's going to tell me what angle A is. So angle A is about, so inverse cosine, 0.4801, 61.3 degrees. Okay, and tangent, so once again, remember this is the ratio of the sides. And we're looking for the angle. So we're going to do the inverse button. So we're going to do inverse tangent of 0.3397, and that will tell me what angle B is. So angle B is about inverse tangent 0.3397, 18.8 degrees. So make sure your calculator is in the right mode. Make sure you're in degree mode. And so that's today's lesson. That was the sine, cosine, and tangent. Just make sure you know what you're looking for. Are you looking for an angle, or are you looking for the ratio of the sides? If you're using your calculator, that depends on whether you actually push the inverse button or just the button on the face of the calculator. So you got to know what you're looking for, ratio of sides or angle. Okay, so anyway, sine, cosine, and tangent, that was this lesson.